All right, functions. We have been talking about logarithmic functions, and we are talking how they relate as the inverse to the exponential function. So we're going to go through some things and talk about some properties and just kind of go through this quickly. So without further ado, let's move on. See if I can get this to work. All right. Okay, so when we first started learning how to solve way back in the day, we would go through and to solve an x plus 5, we would use subtraction to solve. And for this 5x equals 75, we would use division to solve. And this division problem to solve for h, we would use multiplication. And for the square root, we would take it to the second power, we would square it, we would undo it that way. And then to undo this exponent, we would square root it. And then we have this exponent we learned, and we are going to log it. So that's what we're going to do to solve. So we're going to kind of go through some properties so that we can solve, but we really need to know how it behaves and what we can do to rewrite it and how it's going to work and what those things mean to us when we're solving. So first we're going to talk about properties. So we learned that a logarithmic function is anything with a common multiple that's raised to an unknown or something, a variable. Then we have a logarithmic, which is the inverse of an exponential, and we're going to have something like that. And remember, we read that as log base b of a is equal to x. And logarithms always equal an exponent. So if you want to get this in your notes, you can. So the answer to a logarithm is an exponent. I would really like it if you all wrote down number 1. This is a huge deal. It's very important, and you need to just know it. 2 and 3 are just things that we can do, but knowing number 1, that is huge, and for whatever reason, it's the whole point of a logarithm, and for whatever reason, that's something that we tend to forget, so I want to make sure we don't. All right. So when we're talking about finding the inverse of an exponential equation, we've learned how to rewrite this as a log. So converting from exponential to log form, I'm going to show you the operations that you're going to use and things that you're going to need to know. So we're going to log both sides. So if we take log 2 to the 6 is equal to log 64, and then we're going to choose a base. And since our base right here is 2 over here, it's already kind of chosen for us. So we're going to do log base 2 of 2 to the 6 is going to be equal to log base 2 of 64. And then we're going to cancel and drop. So when we have log base 2 raised to another base of 2, they don't cancel necessarily, but they turn into a 1. And we don't typically write our 1s. So the thing that is left is a 6. I would encourage you to write this slide down. You're going to need it. These properties keep coming back. So then the inverse of 2 to the 6 is equal to 64 is 6 is equal to log base 2 of 64, or a way that's more comfortable for me to say log base 2 of 64 is equal to 6. But those two things are the same. So go ahead and get this in your notes, hit pause. So when you're finding an inverse of a logarithmic equation, we're going to convert from logarithmic to exponential. So the first thing we're going to do is we're going to exponentiate each side, meaning that we're going to turn, we're going to turn this into an exponent, and this is already an exponent, so we're just going to turn it into an exponent. So then we have this right here. So we have some base raised to the log base 10 of 100 is going to be equal to something, some base, raised to the second power. Then we're going to choose our base, but our base is already chosen right here, so we're going to choose base 10. So because it's given to us. So now we have a base raised to a log base 10, which means this right here is all going to cancel out, and we're going to end up with just 100 is equal to 10 squared. Well, that's true, right? 10 to the second power is 100. And we know that because this turns into a 1. So the inverse of log base 10 of 100 is equal to 2 is 100 is equal to 10 squared. All right, so let's look at another one. All right, so now we're going to go through some properties. So one of the things is a naturally occurring base is E, and it is a button on your calculator. And I have always remembered that E equals Andrew Jackson, and I can tell you in class someday how I came up with that. A math teacher taught it to me. I've literally, all the math that I've taken, have never needed to know what E equals. So you know how sometimes we have pi, right? And we can use the pi button on our phone, or I'm sorry, our calculator, and we don't really always need to know what pi is, but pi equals 3.14, so it's the same kind of thing. The other thing with pi is sometimes you need to know that it's 3.14. I can just use E. You will always use E. It's a button on our calculator. Know that it's about that number, about 2.7, you know, something like that. All right, so this needs to go in your notes. You need to write down what a common log is. And a common log is log of x is equal to log base 10 of x. And then our natural log is ln of x, and that is equal to log base e of x. So make sure you get that in your notes. Okay, so these are the properties that you're going to want to get down. As you're writing these down, know that this right here are the condensed version of the property, and these right here are the expanded version of the property. So condense, only one log. Expanded, more than one log, except for here, but more than one log of the same base. We also have special properties, which are like the examples we started with, where we have b of log base b of x is equal to x. So, or to that, sorry. This right here, these cancel and turn into a 1, and you're just left with x. These bases right here, oops, cancel, turn into a 1, and you're left with the exponent. So make sure you get that in your notes. All right, so now we're going to go through these examples. So this example we're going to write. So the first thing I'm going to do is I'm going to see that it's multiplication, and when I see that multiplication, that means I'm going to be using the addition property. So I'm going to end up with, oops, my pen is kind of going crazy, log, hold on. Okay, we'll try that again. Log of 3 plus log of 2 to the 3. Now, one of the things that I'm going to do is I'm going to keep the same log and same base. I didn't change any of that. So now I'm going to use the power rule, which says this exponent is going to be thrown out front, and I'm going to end up with log of 3 plus 3 times log of 2. And now that I have everything expanded all the way out, that is going to be my final answer. Okay, so now that we're doing division, we're going to use subtraction. So again, I'm going to keep my log the same, my log and my base. So I'm going to have log, oh, it disappeared. Log of x, and then once I see that division sign when I'm going down on the fraction, I'm going to put a minus sign, and I'm going to have log of y to the 5th. Then I'm going to use the power rule, and I'm going to throw that out front, and I'm going to end up with log of x minus 5 log of y. So that is how we are going to expand those. So make sure you get that in your notes. All right, get these in your notes also. Hit pause. All right, so I'm going to first start by rewriting this as an exponent. So I'm going to have log, and since it's the cube root of x times y times z, then I is going to be x times y times z to the 1/3, which means the 1/3 goes to all of them. So I'm going to rewrite that. So I'm going to rewrite x to the 1/3, y to the 1/3, z to the 1/3. Then I'm going to rewrite this. So I'm going to get log x to the 1/3. I have a multiplication there, so I'm going to write plus log y to the 1/3. I have another multiplication, so I'm going to write plus log of z to the 1/3. So now I got to do the power rule, which says that I'm going to take the exponent and throw it out front. So I'm going to get 1/3 log of x plus 1/3 log of y plus 1/3 log of z. Make sure you notice that this is a log. There we go. All right. Again, I'm going to rewrite this so that I can get the exponent with it. So that is log 6 to the 5th over 11 to the 5th, because that goes to both of them. And then I'm going to rewrite it. So I'm going to have log 6 to the 5th minus log 11 to the 5th. Again, we aren't multiplying. We're not simplifying these numbers, so don't worry about multiplying them. And then I'm going to get 5 times, I'm going to use my power rule, log of 6 minus log, oops, I forgot the 5. 5 times log of 11. Okay, so that is how we are going to expand. All right, so now we're going to work our way the other direction. We're going to start from an expanded and we're going to condense. So the first thing I'm going to do is write, I can see that they're all the same log, so I'm going to write that one time, log. And then I'm going to start with my first one, which is 2. And then I have a plus sign, so I'm going to add times. And then I'm going to write the number since I already took care of the log. And then I have another plus sign, so I'm going to write times and 7. And then I'm going to put this in parentheses, and I'm done. That is it. Again, I'm going to do the same thing over here. I can see that natural log is the same thing, so I'm going to use my natural log. I have subtraction, so I know I'm going to be going with division. So my numerator is going to be x. My denominator is going to be y. And then this is like the reverse power rule, so I'm going to take this and make it over here, y to the 4th, and I am done. This is the same thing, so go ahead and hit pause and try these on your own. I'm going to write the answers, but hit pause. Okay, so since this is addition, you should have seen that it was multiplication. So the first thing I did is I did the reverse power rule, so I got log base 6. Something I want to make note of, this is something called a subscript. We talked about this in matrices. So a subscript is it goes below the line and it's small. So it's the opposite of like taking something to a power, it's going below. So make sure when we type that in our answers in my math lab, we do a subscript. You also can type the word log, just L-O-G, and then use your subscript button, and that'll give you the base. So I got log base 6 of u to the 20th plus log base 6 of v to the 5th. Then I condensed it even further, and I got log base 6 of u to the 20th times v to the 5th. And then I did the same thing over here. I did the reverse power rule, and I got log base 3 of u to the 4th minus log base 3 of v to the 20th. And then I condensed it down to just one log, and I got log base 3 u to the 4th over v to the 20th. So that is something that you're going to want to do. You should be able to get through number 22 on our My Math Lab. So if you have any questions, please let me know. Otherwise, I will see you all in class. Bye!